Hello friend, you are most welcome to my channel. Let's in this video we discuss your exercise 1.3 question number 6 of your textbook page 14. And what are the question? Here is the question is that look at several example of rational number in the form of p by q where q not equal to 0, where P and Q are integer with no common factor other than 1 and having terminating decimal representation or expansion. Can you guess what property Q must satisfy? But here the question is like that you have to choose a fraction P by Q form where two things should be fulfilled with both P and Q no common factor other than 1 and terminating decimal expansion. After that you have to say what property Q must satisfy so that like this fraction can possible. Let's we explain the question little nicely in the next page. Come here. Here question is asked that we must be choose a fraction P by Q form where Q not equal to 0. Then we have to choose a fraction, but two things we must be take care. First thing, both P and Q with no common factor other than 1. This is the first point. Next point is Q must satisfy such a property, then their decimal expansion should be terminating decimal expansion. Their decimal expansion should be terminating decimal expansion. There is a 2 point. P and Q, they no common factor other than 1 because they have only common factor of 1, not other common factors. Then Q must satisfy so that the decimal expansion should be terminating decimal expansion, and P and Q both their common factor must be 1, no other common factor. Before solving this one question, I like to explain about the factor and common factor. I have to explain about the factors. First you understand the meaning of the factor. What are the factor is? Factor. If I say 2 is a factor of 10. Let's check. 2 is a factor of 10 or not. 2 a factor of 10 means 10 is divisible by 2, means 2 5s are 10 with remainder 0. If we divide the 10 by 2, the remainder comes 0, means 2 is a factor of 10. In this way, 3 is a factor of 9. 3 is a factor of 9, means 3 can divide 9 completely with remainder 0. Let's see. 3 3s are 9. Here you see 3 divide the 9 completely with remainder 0, means 3 is a factor of 9. In this way 2 is a factor of 10. In this way 10 has many factors. You see 10 can be divided by 1, 10 can be divided by 2 also, 10 can divide by 5 also, means 1, 2, 5s are all factors of 10. Similarly 9 has also many factors. 1 can divide 9, 3 can divide also 9, 9 itself also divide by 9. Okay, here also 10 itself also divide the 10, means 10 itself also factors. Okay, 10 also is a factor. Same way 1 also factor of 9, 3 also factor of 9, 9 itself also factor of 9. This is called as factor. Then come for the common factor. Here is the question is here common factor. Which one called as common factors? Let's explain about the common factor. Common factor. What do you mean by common factor? Just like I see the factor of 5 you say 1 and 5. Then factors of 10 you see 1 also, 2 also, then 5 also. Here is the common is here 1 is the common and 5 also common. Then both common factor of 5 and 10 is here 1 and 5. In this way both number their common factor is 1 and 5. Means here also factor of 5 is 1 and 5, factor of 10 is 1, 2, 5, and both one have common their factor. Some are common, means 1 is the common and 5 is the common. In this way others number also have common factor. This is the I explain here. This is a factor and common factor I explain. Then here is the question we have to fulfill the two things. We find the rational number in a fractional number in the form of p by q where both should be terminating decimal expansion and both should no common factor other than 1. It means that we have to choose two number. Their common factor is just only 1, not others. Just like take one example. Let's see, one example is here. This one example we take 10 and 9. 10 their factor is 1, 2, 5 and 10. 9 is the factor of your 1, 3 and 9. Both number have only 1 is the common factor. Both number as 1 is the common factor. Their common factor is only 1. Okay, then in this way we have to choose such a number means like this, such a number their common factor should be 1. Their common factor should be 1. First thing, this is the point we take care. Only their common factor should be 1 and both numerator denominator their fraction should be terminating decimal expansion. On dividing, their decimal expansion should be terminating decimal expansion. This is the questions. Okay, now let's we write few rational number and fraction where decimal expansion should be terminating and fulfilling the both the point. Let's we go through it. Let's take first example. Let's consider few examples. This is the few example we consider. Just you see 13 by 8 here 1.625. You see this two you divide. This two you divide, you get 1.625. How I get? You see 13 you divide by 8. One time you give 8, then your 5. Here is a point 0. Here is a point 0. 8 6 are 48. Then 2. Then 0. 8 2s are 16. Then 4. For here is the 0 can give because of decimal. Then here also 0 came. 8 5s are 40. 0. Here is the this one 13 by 8 your decimal expansion is 1.625. Okay, now you consider another example 17 by 10 your 1.7. This one divide, you get 1.7. Then 9 you consider 9 by 4. What is the decimal expansion of this one? Let's see. 9 4 2s are 8. 1 for decimal 0 you give. Here also decimal come. 4 2s are 8. 2. Here is the 0. 4 5s are 20. Okay, now your 2.25. Then last one more example, 11 by 8. Then this one we divide, let's see, 11 by 8. 8 ones are 8. Then 3, here give decimal 0, here also decimal 0. 7, 8, 8 threes are 24. Then 6, here also 0, here also 0 come. 8 sevens are 56. 4, here also 0, give 0 here. 8 fives are 40. Okay, 8 fives are 40. Then 1.375. This one you see, this is a terminating decimal expansion. These are terminating decimal expansion. Same way, these are also terminating decimal expansion. These are all terminating decimal expansion. In this terminating decimal expansion, you see, this is the Q. This is the Q denominator. Denominator is your prime factorization of, let's see, 8 you see, 8 1. Prime factorization we do. 2 4s are 8. 2 2s are 4. 2 1s are 2. 8 is your prime factor of 2 and 2. Clear? 2 and 2. Then your 7, here is this one. 10 is a prime factor of 10, you see. 2 5s are 10. Means 10 is the prime factor of 2 and 5. And 4 also prime factor of 2 into 2. Means 2 is the only prime factor. 8 already said, you see, 2 into 2 into 2. These are all number. These are all these numbers, they have the prime factor of 2 and 5 only. Clear? Means for terminating decimal expansion, Q must be, Q denominator, Q must be prime factor of 2 and 5. Clear? 2 and 5. Here is the all denominator are prime factor of 2 and 5. Here is a 2 and 5. This one should be satisfied. Then next one, both P and Q satisfy the common factor of 1. Both have common factor of 1. Let's see how it is common factor of 1. You see, 13 1 factor, you see, 1 and 13 only. Then your 8 your common factor is your 1, 2, 4, number itself 8. Their common factor is only 1. Their common factor is only 1. Similarly, this number also same way, you see, their common factor, you check here somewhere, you check 17 1 factor is 1 and 17. 10 common factor, 10 factor is 1, 2, 5 and 10. Their common factor is only 1. Okay, their common factor is only 1. Mean two things we should be satisfied. Denominator Q should be prime factor of 2 and 5. This is called a prime factor. This is called a prime factor. In this way we find a prime factor. This one called a prime factor. There should be prime in the factorization. There should be presence of 2 only, otherwise 5 only, or both 2 and 5. Here you see both 2 and 5. Here is a 2 only. Here is a 2 only. Here is a 2 only. Some question may be only 5 only. Just like 25 you say. 25 you see only 5 only prime factor. Okay, 5 only. We should be only 5 only or 2 only or both 2 and 5. Okay, Q must be prime factorization of 2 and 5, and both P and Q should be common factors of 1. There should be common factor of 1. Then it is possible, it will become terminating decimal expansion. It will become terminating decimal expansion with no common factor other than 1. Means only 1 is the common factor. Then it possible. Here also you see both number numerator denominator on dividing come terminating decimal expansion, and also both their common factor is 1, only 1. With here the question is asked like that. Here we should be no common factor other than one means both P and Q their common factor only one, not other common factor. Then next one here, terminating decimal expansion. These two things we should be take care and fulfill this one. Then can you guess what property Q must satisfy? Q must satisfy the prime factorization of 2 and 5 or both. Clear? This should be the property of 2 and 5 or both should be satisfied. This is the question is here is already I already explained and answered this one. Last we come for the conclusion of this question. Let's see. I am going to write a conclusion of this question. Final answer. Let's see here. Their final answer is, you write like that. You see, rational number in the form P by Q where Q not equal to 0, where P and Q are integer with no common factor other than 1 means both P and Q only common factor of 1, not other common factor, and having terminating decimal representation or expansion. For that means for this one thing we should be fulfilled, then what point we should be consider? We should be consider denominator Q must satisfy the property of prime factorization of 2 only and 5 only or both. Means Q must satisfy the prime factorization of 2 and 5. Prime factorization of 2 and 5. Only 2 or only 5, otherwise both 2 and 5. Okay, then one more point is numerator P must not prime factor of 2 and 5. Means numerator P should not be prime factor of 2 and 5. Other than prime factor of 2 and 5, you choose such number. Here you see, consider you see, this one 13 P, this one 13 P. This is not prime factor of 2 and 5. Here is the prime factor of 1. Here is a 13 is here 1 and 13 P. P is the 1 and 13. Same way 17 you see, this is a prime factor of 1 and number itself. You 9 1 you see, 9 is a prime factor of a prime factor of 3 and 3. Okay, there is a their common their prime factor is 3 and their factor is also 1 and 3. there is a factor of 1 and 3. Okay, this one don't consider. This one you see 9 is the prime factors of 1 and 3. Let's consider P should be the factor, not factor of 2 and 5. Okay, P should not be the common factor of 2 and 5. Just see the P should be your other than 2 and 5. 1 and 13 you see, next 17 you see, here 17, there also 17 is your 1 and 17, then 9 you see, 3 and 3, then 11 your 1 and 11. In this way their factor should not be 2 and 5. Then we can fulfill then P and Q are integer with no common factor other than 1. No common factor other than 1. Then we can, for this thing, we should be fulfill these 2 points, then it possible. Dear friend, our last little more discussion. Let's consider one example. 75 by 20. Their decimal expansion count come 3.75. These are also terminating decimal expansion. Okay, but one thing is here, you see this one prime factorization you have to do. Their factor is your factor, their factors come 1, 5, 10 and 75 like that come. There 21 also you do. Here 1, 2, 5, 10, 20. But here is a both one common factor, you see, 1 also common factor, 5 also common factor, 10 also common factor. But our question 1 demand is not fulfilled. No common factor other than 1. Like this fraction, if you choose, there have more common factor other than 1, because their common factor is 3 common factor. But question is demanded for only 1 should be the common factor. 1 common factor should be only 1, not 5 and 10. This one should be take care. Because of that reason, P, your numerator should not be your prime factor of 2 and 5. Because if numerator is not prime factor of 2 and 5, then we can easily fulfill both one common factor of your 1 only, other than 1. Okay, therefore we should consider such a numerator. It should not be the factors of 2 and 5, but P should be the prime factorization of 2 and 5, and Q should be prime factor of 2 and 5, and P should not be the prime factors of 2 and 5. Okay, this one keep in our mind. Okay, then we should choose such a fraction, then we fulfill our questions demand, then our get the required example. In this video we discuss a lot of this thing. I hope you will understand and wait for the next video. You watch this one video completely up to this much. Thank you.